$10 billion James Webb Telescope took off from Earth, with that beginning its mission to show the first stars to light up the universe.
NASA has released more photos from the world's most powerful telescope, revealing the deep secrets of space.
Now, the first image from the world's most powerful space telescope, James Webb, is here. The image, which shows a small slice of the universe called SMACS 0723, has been captured in sharp detail by the telescope.
What if everything we know about the universe is only part of the story? For decades, we've believed the Big Bang was the beginning, the moment everything burst into being. But what if it wasn't a solo act? What if the Big Bang created not just our universe, but a cosmic twin, a parallel reality that mirrors our own, but runs in reverse? Sounds like sci-fi, right? But thanks to a game-changing discovery from NASA's James Webb Space Telescope, this idea is suddenly being taken very seriously by some of the world's leading physicists. Here's the scoop. Webb has been peering deeper into space and further back in time than any telescope before it. And what it's found is shaking the foundation of modern cosmology. Way out in the early universe, just a few 100 million years after the Big Bang, Webb is spotting massive, bright, fully formed objects. Galaxies, huge ones, and according to everything we thought we knew, they shouldn't even exist yet. They're too big, too luminous, and way too well structured to have formed so soon. Imagine walking into a nursery and finding a fully grown adult sitting in a crib. That's how bizarre this is. And this isn't just a little anomaly. It's the kind of discovery that could rewrite the rulebook of the cosmos. It's forcing scientists to take a long, hard look at ideas they once laughed off. One of the wildest possibilities? That what we're seeing could be the first physical signs of another universe. One that didn't just start alongside ours, but is unfolding in reverse, running backward in time. But before we can even wrap our heads around that mind-bender, let's rewind and revisit the cosmic story we've all been taught. Our best scientific model, the standard model of cosmology, says the universe began 13.8 billion years ago with the Big Bang. At that moment, there was no space, no time, just a single, unimaginably hot and dense point. Then, boom, it all expanded. In just a fraction of a second, the universe inflated faster than the speed of light, creating space-time itself. As the universe began to cool, the fundamental forces and particles we know today started to take shape. But for the first 380,000 years, the cosmos was a thick, seething fog of plasma, so hot and dense that light couldn't travel through it. Astronomers call this period the cosmic dark ages. Only when things cooled down enough for electrons to bond with atomic nuclei, forming the first hydrogen and helium atoms, did the fog lift. Light was finally free to move through space. That ancient light, we can still detect it today as the cosmic microwave background, a glowing fossil from the birth of the universe. From that moment on, the universe was supposed to grow slowly and steadily. Tiny fluctuations in the density of matter eventually formed stars, then galaxies, then clusters of galaxies over billions of years. But now, the James Webb Space Telescope has thrown a cosmic wrench in that timeline. Because what it's seeing, those impossibly early galaxies, they're too perfect, too developed, and far too early. Which begs the question, are we missing something fundamental about how the universe works? Or, more boldly, are we peeking into the fingerprints of a second universe, born with ours, yet evolving on a totally different clock? Let's rewind to the early universe, right after the Big Bang. Gravity, the quiet powerhouse behind everything, started its work. Slowly, patiently, it began pulling together tiny clouds of hydrogen and helium, the only elements that existed back then. No stars yet, no planets, just raw, floating gas. Over hundreds of millions of years, those gas clouds were supposed to collapse under their own weight. That's how the first stars were born, massive, hot, and brilliant. These weren't your average stars. They were beasts, burning bright, burning fast, and dying young. When they exploded in powerful supernovae, they scattered heavier elements, carbon, oxygen, iron, all the building blocks needed to eventually make planets and life. After that, gravity took the reins again. It started clumping those first stars into tiny baby galaxies. Nothing like the grand spirals we see today. Just small, clumsy clusters of stars wobbling through the void. But here's the key part. This entire cosmic construction project was supposed to take time. A lot of time. Galaxies weren't supposed to just pop into existence. They were supposed to slowly form, then smash into each other, merge, evolve, and grow over billions of years. According to the standard model of cosmology, the universe had a strict speed limit when it came to building complexity. But guess what? The James Webb Space Telescope just blew right past that limit. Webb, the most powerful telescope we've ever launched, a literal time machine, was designed to look back to the earliest moments of the universe, what scientists call the cosmic dawn. And what it's seeing up there, total bombshell. Instead of finding those baby galaxies just starting to come together, Webb is spotting giant fully formed galaxies way too early in the timeline. It's like showing up at a toddler's birthday party and finding them filing taxes and driving a car. These galaxies are bigger, brighter, and more organized than they should be, just a few 100 million years after the Big Bang. According to everything we thought we understood, they just shouldn't be there. So now the big question is, what broke the rules? Is our model of the universe flawed? Is there something fundamental we're missing about how stars and galaxies form? Or are we seeing signs of something far stranger hiding beneath the surface of our cosmic history? Either way, one thing's for sure. Webb didn't just give us a better view of the universe. It may have just rewritten how we think the universe came to be. As the James Webb Space Telescope stared deep into the darkness, peering back over 13 billion years, it uncovered something no one saw coming. Not baby galaxies, not cosmic toddlers fumbling their way through the early universe. Nope, it found monsters. Scientists expected to see faint, chaotic clumps of matter, early, unshaped proto-galaxies just starting to form. Think of it like spotting sparks before a fire catches. But instead, Webb spotted galaxies that were already enormous, already mature, already far too advanced for their age. One of them? It existed just 290 million years after the Big Bang. To put that in perspective, the universe was less than 3% of its current age. And yet, this galaxy looked like it had already been hitting the cosmic gym for a few billion years. It's the astronomical version of walking into a delivery room and finding a full-grown adult in a business suit asking for a coffee. Now let's compare. Our own galaxy, the Milky Way, took over 13 billion years to become what it is today. A vast spiral city of stars, planets, dust, and life. It grew slowly, piece by piece, like a giant jigsaw puzzle coming together over eons. But Webb is now finding a whole population of galaxies that seem to have skipped the entire toddler phase of the cosmos. And this isn't some one-time fluke. These galaxies keep showing up in Webb's deep field images. So many, in fact, that some astronomers have started calling them universe breakers. Because, well, their very existence seems to break the rules we've lived by for decades. It's like digging into ancient rock and finding a T-Rex fossil in layers that predate dinosaurs by millions of years. The fossil's there. You're holding it, but it shouldn't be possible. That's the level of weird we're dealing with. The images are real. The galaxies are undeniably there. But according to our most trusted models, the rules that shape everything from textbooks to theories, they simply shouldn't have had enough time to form. And that's what has cosmologists around the world seriously rattled. Because this discovery isn't just confusing, it's threatening to overturn the foundation of how we understand the entire timeline of the universe. Which leads us to the big, terrifying question no one wanted to ask. What if the rules are wrong? These massive, super early galaxies are throwing a huge wrench into the standard story of how the universe works. At the heart of the problem, the speed of light, the ultimate cosmic speed limit, which also sets the pace for how fast gravity can pull things together. Picture the early universe like a faint, thin fog made of gas spread out everywhere. Now, to build a galaxy that's packed with billions of suns worth of material, gravity has to pull all that gas together from the surrounding space. But here's the kicker. Gravity can only pull that matter in as fast as light travels. So at just 290 million years after the Big Bang, basically the universe's toddler years, there just wasn't enough time or reach for gravity to gather enough gas to build these huge galaxies. It's like trying to construct a skyscraper in 1 week, but you're only allowed to grab bricks from your front yard. No deliveries, no extra help, just what's right there. Physically, it's impossible. And even if the gas could be pulled in that fast, the next step, turning all that gas into stars, is another slow burn. The gas has to cool down and condense before stars can even flicker to life. Normally, building a galaxy this massive means multiple generations of stars forming and dying, plus galaxies colliding and merging over billions of years. But these Webb discoveries, they suggest that whole process somehow zipped by in the blink of a cosmic eye. Scientists are honestly scrambling right now, trying to figure out how this could be. Some think maybe we're overestimating how massive these galaxies actually are. Others propose that supermassive black holes, forming in a mysterious way we don't fully understand yet, could be acting like gravitational anchors, pulling everything in super fast. But here's the thing, none of the usual explanations fully fit the bill. And that's what's pushing some researchers to get really creative and start wondering if the answers lie outside the universe as we know it. To really wrap our heads around this wild idea, we need to dive into one of the most mind-bending concepts in physics: symmetry. Physics isn't just random rules thrown together. It's built on deep, fundamental symmetries. One of the biggest and most important is something called CPT symmetry. That stands for charge, parity, and time. Here's the gist. If you took our entire universe and swapped every particle for its antimatter twin, then flipped everything like you're looking in a cosmic mirror, and finally ran time backward, surprisingly, that new mirror universe would follow the exact same laws of physics as ours. Sounds like sci-fi, right? But it's pure math, and it's seriously elegant. For a long time, CPT symmetry was mostly just a cool mathematical curiosity. But what if it's actually real? What if the Big Bang didn't just kick off one universe, but two? That's the heart of the CPT symmetric universe theory. It suggests our universe has a twin, a mirror image universe, running in the opposite direction from the Big Bang, where, from our point of view, time actually flows backward. So, the Big Bang wasn't a one-time starting line. It was more like a cosmic reflection point, a moment where two universes sprouted in opposite directions. This idea isn't just strange, it's powerful. It neatly solves some of the biggest mysteries out there. For starters, it explains the arrow of time, why time moves forward for us. Even more impressively, it tackles the baffling question of antimatter. According to the standard story, the Big Bang should have made equal parts matter and antimatter, which should have instantly destroyed each other, leaving behind nothing but pure energy. But here we are, clearly made of matter, with hardly any antimatter to be found. The CPT symmetric model says that antimatter isn't missing. It's just hanging out in the other universe, the mirror one. Together, the two universes balance each other perfectly. For decades, this idea has been fascinating, but pretty much out of reach. Too speculative, too tough to test. But now, thanks to new observations, that might be changing. So, how does this mind-bending idea about a mirror or anti-universe actually explain the very real galaxies we're spotting out there? Well, the link is just as speculative, but it involves one of the biggest cosmic mysteries we face: dark matter. We know dark matter makes up about 85% of all the matter in our universe. It's invisible, but its gravity is what holds galaxies together, acting like a cosmic skeleton that gives structure to everything we see in the sky. Now, the standard model includes dark matter, but here's the catch. It still struggles to explain how this invisible stuff could have clumped fast enough to form the massive halos that galaxies need, especially the ones Webb is detecting, which seem way too grown up for their age. This is where the CPT symmetric universe theory throws us a fascinating curveball. According to this idea, dark matter might actually be a specific type of particle, a super heavy version of a neutrino called a sterile neutrino. These particles are predicted to have been created in massive amounts. And get this, they might exist not just in our universe, but in that mirror anti-universe too. If this crazy theory holds water, then our universe is basically flooded with these heavy neutrinos streaming in from its cosmic twin. And that changes the game completely. Because these particles would have started pulling together under gravity way before the first atoms even showed up. They'd formed dense, invisible scaffolding all over the cosmos. So when regular matter finally came along, it didn't have to build everything from scratch. Instead, it would have just fallen into these already formed dark matter halos, sparking a turbocharged phase of galaxy formation, way faster than anything our current models allow. In other words, those impossible galaxies Webb found, they're not impossible at all. They're actually what you'd expect if the universe was built on a foundation laid down before anything else even got started. It's a jaw-dropping idea. Like discovering your house was built on an ancient, hidden basement you never knew existed. What if the biggest, most massive structures in our universe owe their very existence to an invisible cosmic scaffolding, built not by our universe, but by a hidden mirror universe running backward in time? Sounds like sci-fi, right? Well, there's no direct proof yet, but the puzzling discoveries from the Webb telescope have pushed some scientists to seriously consider that maybe, just maybe, the answer has to be this wild. This idea of a CPT symmetric mirror universe is just one of several mind-blowing theories on the table. The baffling clues Webb has uncovered are forcing researchers to stretch far beyond the standard model we've relied on for decades, nudging us toward the possibility that reality itself might be way stranger than anything we ever imagined. These ideas fall under the vast, mysterious umbrella of the multiverse, a concept that's been gaining traction in theoretical physics. Take the inflationary multiverse, for example. It proposes that right after the Big Bang, certain patches of space stopped inflating and became bubble universes like ours, each with potentially different physical laws, all floating together in an endless cosmic foam. Then there's the brain, or brain, multiverse, which comes from string theory. Picture our entire universe as a membrane, or brain, floating in a higher dimensional space. There could be other brain universes drifting nearby, and if two of these ever collided, it might trigger another Big Bang, spawning new universes. Yeah, it sounds like stuff straight out of a blockbuster sci-fi flick. And for now, these ideas remain firmly on the frontier of theoretical physics, with no direct proof in hand. But don't mistake them for wild guesses. They're mathematically solid possibilities, rooted deeply in the most advanced physics theories we have. The strange early galaxies Webb keeps revealing, the ones that shouldn't exist according to our standard cosmic timeline, are exactly the kind of clues scientists have been hoping to find. These are the moments when the standard model starts to unravel, showing its rough edges. And it's right there, in those frayed edges, where a whole new, richer understanding of reality might be waiting. Webb's discoveries have cracked open a thrilling and mysterious new chapter in our quest to understand the cosmos. We're now facing objects that challenge everything we thought we knew about the universe's timeline, and they're forcing us to entertain ideas that stretch the limits of our imagination. So, what do you think? Are these enormous early galaxies proof that our cosmic models are just incomplete? Or could they be the faint echo of a universe or multiverse far larger and stranger than we've ever dreamed? Drop your thoughts and wildest theories in the comments below. Because one thing's clear, the universe, or multiverse, is just getting started. NASA just dropped a cosmic bombshell. There might be not one, but two universes, and Webb has spotted something downright terrifying lurking in the void. If you're into parallel universes, mysterious cosmic objects, and space plot twists that blow your mind, hit that subscribe button and buckle up. You're in for the wildest ride through the cosmos.